In this section, let's meet and explore the Kubernetes package manager, Helm. Helm is a package manager for Kubernetes. It is similar to apt for Ubuntu or Homebrew for macOS. Borrowing a package manager definition from Wikipedia, a package manager is a collection of software tools that automates the process of installing, upgrading, configuring, and removing computer programs for a computer in a consistent manner. In Kubernetes, or to be specific, in the Helm terminology, packages are called charts. So when you hear the words Helm charts, then it actually means packages. These packages are pre-configured, reusable Kubernetes resources that can be installed in your cluster. Let us consider that you want to install the ELK stack in your cluster to help log data and monitor your application. If we have to run the ELK stack using Kubernetes, then we need to create more components like stateful sets, config maps, secrets, create users with some permissions, and also create services. By the end of your own creation of consuming ELK stack in Kubernetes, you would have 5 to 6 YAML files that you need to manage going forward. That is to create and manage ELK log monitoring solution in your cluster, you would need to create and manage 5 to 6 YAML files. How about if someone already created the required components for the ELK stack, packaged the needed YAML files, and shared this package somewhere in the internet? Then you could reuse this bundle of package in your cluster instead of creating all the components from scratch. The bundle of package that defines what Kubernetes components should be installed and configured is called Helm charts. Installing Helm charts is similar to how you would install packages in your Linux operating system. The code snippet here shows a simple command that compares installation of packages in Linux using apt and installing Kubernetes packages using Helm. Isn't it simple? With only the install command, you were able to add a WordPress package and did not have the hassle of creating services, secrets, and other Kubernetes components. Helm did the creation of services, secrets, pods, and other components for you in the background, and we just had to run the Helm install command. Let's us learn about the Helm architecture by understanding each of the components in Helm. Helm 3 is the current release of Helm, but support for Helm 2 still exists. So it is good to know how Helm 2 and Helm 3 differ in architecture. Helm 2 is a client-server architecture, where the client is called Helm itself and server is called Tiller. The client Helm allows the user to perform operations like install, upgrade, delete, and so on. As portrayed in the picture, Helm client interacts with the chart repository and gets the requires chart for the user, and then it interacts with the Helm server, which is called Tiller. Tiller is used to deploy almost any Kubernetes resource. To deploy resources, by default, Helm takes maximum permissions to make changes in the Kubernetes. This is a security concern because anyone who can talk to Tiller can also modify Kubernetes cluster resources. Also, the fact that Tiller by default does not have authentication is a severe security concern. Imagine a malicious container of a pod in a cluster that has permissions to talk to Tiller, then the malicious component can potentially compromise the entire cluster. Considering all the risks in Helm 2, the Kubernetes community wanted a more secured way of communication with API server. Tiller was good, but it was not the most secure way of communications in production deployment scenarios. DevOps and security teams had an additional overhead of managing the security of Tiller itself. So, Tiller was eventually removed from Helm. Helm 3 has a client-only architecture where the client Helm directly speaks to the Kubernetes API server, leveraging the access level of API server itself. A chart is a collection of files organized in a specific directory structure. Using charts, we create an instance of a Kubernetes application. The chart has all the needed dependencies required to run a Kubernetes application. Repository holds collections of charts. It is like an online store where you could search for available charts. You can search, download, and install a chart from a repository. There is a distributed community chart repository by the name Artifact Hub, where you would find publicly available Helm charts. We can also create our own private chart repositories if required. Release is a specific instance or a deployment of a chart. When you perform a Helm install command, you are creating a new release of a certain Helm chart on your Kubernetes cluster. A chart is a collection of files that help install Kubernetes application. A release is an instance or a deployment of a chart, and a repository is a place to store and distribute charts. I hope you have enjoyed this lecture. We will move on to the next lecture.